Our brains are incredible organs, processing vast amounts of information every second. But what happens when this intricate system plays tricks on us? We experience a fascinating phenomenon. Our own brain, the source of our perceptions, becomes a master of deception. From our sense of smell to our visual perception, our brain constantly filters and interprets information, sometimes leading to surprising and even amusing inaccuracies. These brain lies aren't malicious. Instead, they highlight the brain's remarkable ability to navigate a complex world by prioritizing certain sensory inputs over others. Let's return to our bakery example. The initial wave of freshly baked bread aroma hitting your senses is intoxicating. Yet, within minutes, the smell fades into the background. This isn't because the bakery's aroma has vanished. It's your brain engaging in olfactory fatigue. This fascinating phenomenon, also known as nose blindness, occurs when our olfactory receptors, responsible for detecting smells, become saturated with a particular odor. Think of these receptors like tiny sensors sending signals to the brain. Constant exposure to the same odor overstimulates these sensors, causing them to fire less frequently. The brain, in turn, receives a weaker signal, leading to a decreased perception of the smell. Essentially, our brain gets used to the smell, allowing us to focus on other, potentially more crucial scents in our environment. Our senses rarely operate in isolation. They are constantly working together, creating a seamless experience of the world around us. They often collaborate, influencing and shaping each other in fascinating ways. This interplay is crucial for our perception and understanding of our environment. The McGurk Effect, a compelling auditory illusion, perfectly demonstrates this sensory interplay. It shows how our senses can sometimes deceive us, leading to surprising and unexpected results. This illusion highlights how our visual system can dramatically alter our auditory perception, leading to a perceived sound different from the actual sound presented. Imagine watching a video where the visual and auditory inputs don't match. A person on screen is clearly mouthing the syllable GA. You can see their lips forming the shape of the sound. However, the audio track plays the sound BA. Your ears hear one thing, but your eyes see another. Surprisingly, what we perceive is neither GA nor BA, but the syllable DA. This new sound is a blend of the visual and auditory inputs. This intriguing phenomenon occurs because our brain, attempting to make sense of conflicting visual and auditory information, combines the two inputs, creating a compromised sound. It's a testament to the brain's adaptability and its efforts to create a coherent experience. The McGurk Effect underscores the dominance of visual cues in speech perception. Our brain often trusts what it sees more than what it hears. Our brain, accustomed to relying on visual information from lip movements and facial expressions to interpret speech, often prioritizes these cues over auditory information. This reliance on visual cues can sometimes lead to perceptual errors. This visual bias highlights the brain's remarkable ability to integrate sensory information, even when it results in a perceptual illusion. It shows how our senses are interconnected and how they work together to shape our perception of reality. The McGurk Effect is just one example of the complexity of sensory processing in the brain. It reminds us that our perception is not always a direct reflection of reality, but rather a constructed experience influenced by multiple sensory inputs. Understanding phenomena like the McGurk Effect can give us deeper insights into the brain's adaptability and the intricate ways in which it integrates sensory information to create our experience of the world. Section 4. Motion-induced blindness. When seeing is not believing. Our visual system, while remarkable, is not without its limitations. Motion-induced blindness, a striking visual phenomenon, reveals the fascinating ways our brain can filter out information, even when it's right before our eyes. This illusion occurs when a stationary object disappears from our awareness when surrounded by moving visual patterns. Imagine staring at a central point while small dots move around it. Surprisingly, if a larger stationary object is introduced in the periphery, it can vanish from our perception intermittently. This happens because our brain, focusing on the moving dots, prioritizes motion information over stationary objects. Section 5. The Symphony of Senses. How colors and sounds affect taste perception. Taste, often considered a singular sense, is actually a complex interplay of various sensory inputs. When we take a bite of food, it's not just our taste buds that are at work. Our brain is busy processing a multitude of signals from different senses to create the overall flavor experience. While our taste buds play a crucial role in detecting basic tastes like sweet, sour, salty, bitter, and umami, our perception of flavor is heavily influenced by other senses, particularly sight and sound. This multi-sensory integration is what makes eating such a rich and varied experience. Consider the color of food. The visual appeal of a dish can set the stage for our taste expectations even before we take the first bite. Studies have shown that altering the color of a beverage, for example, can influence our perception of its taste. In one experiment, participants were given the same drink, but in different colors, and their taste ratings varied significantly based on the color they saw. A bright red beverage might be perceived as sweeter than a pale yellow one, even if they have the same sugar content. This is because our brain has learned to associate certain colors with specific tastes over time. This happens because our brain associates certain colors with specific tastes, influencing our overall flavor experience. For instance, we might expect a green-colored drink to be sour or minty, while a brown one might be associated with a rich, chocolatey flavor. Sound also plays a surprising role in taste perception. The auditory cues we receive while eating can significantly enhance or detract from our enjoyment of food. The crunch of a potato chip, the fizz of a carbonated drink, or the sizzle of a steak can enhance our enjoyment of food. These sounds are often associated with freshness and quality, making the eating experience more pleasurable. These sounds often signal freshness and texture, contributing to a more satisfying sensory experience. The fizz of a soda, for example, not only adds a tactile sensation, but also an auditory one that we associate with refreshment. In contrast, eating a soggy chip or a flat soda is less appealing, partly due to the lack of auditory cues that typically accompany these foods. The absence of these sounds can make the food seem stale or less enjoyable. The interplay between taste, sight, and sound highlights the multisensory nature of flavor perception. Our brain is constantly integrating these different sensory inputs to create a cohesive and enjoyable eating experience. Our brain seamlessly integrates these sensory inputs, creating a harmonious symphony of sensations that shape our overall dining experience. This complex interaction is what makes eating not just a necessity, but a delightful and memorable experience. Section 6. The evolutionary advantage of sensory deception. At first glance, the idea of our brain deceiving us might seem disconcerting. It can be unsettling to think that our perceptions are not always accurate reflections of reality. However, these sensory deceptions, far from being flaws, are testament to the brain's remarkable ability to adapt and prioritize information for our survival. Our brain has evolved to filter and interpret the vast amount of sensory data it receives, ensuring that we focus on what is most crucial for our immediate needs and long-term survival. These brain lies have likely evolved over millennia, providing us with evolutionary advantages in navigating a complex and ever-changing world. In the wild, where early humans faced numerous threats and opportunities, the ability to quickly and efficiently process sensory information could mean the difference between life and death. Olfactory fatigue, for instance, prevents sensory overload, allowing us to focus on new and potentially significant scents while filtering out constant, unchanging odors. This mechanism ensures that we are not overwhelmed by the myriad of smells in our environment, enabling us to detect important changes, such as the presence of food or danger. This ability would have been crucial for our ancestors in detecting predators, locating food sources, or identifying potential dangers. By filtering out background odors, our ancestors could remain alert to new and potentially life-threatening scents, enhancing their chances of survival. The McGurk Effect, while an illusion, highlights the brain's preference for visual cues in speech perception. This phenomenon occurs when conflicting visual and auditory information leads to a third, distinct perception, demonstrating how our brain integrates multiple sensory inputs to create a coherent understanding of our surroundings. This bias likely stems from the importance of visual information in social interactions, allowing us to interpret facial expressions, body language, and lip movements to understand communication more effectively. In social settings, the ability to accurately read visual cues can enhance our interactions and help us navigate complex social dynamics. Motion-induced blindness, while potentially hazardous in certain situations, might have helped our ancestors focus on moving prey or predators while ignoring irrelevant stationary objects in their visual field. This selective attention would have been advantageous in hunting and avoiding danger, ensuring that our ancestors could react swiftly to critical changes in their environment. This ability to prioritize motion information would have been crucial for survival in a hunter-gatherer society. By focusing on movement, our ancestors could better track prey and evade predators, increasing their chances of successful hunts and safe escapes. These examples demonstrate that the brain's tendency to deceive us is not a malfunction, but rather a sophisticated adaptation. Our brain's ability to filter, prioritize, and sometimes distort sensory information has been honed over millions of years to enhance our survival and reproductive success. By filtering, prioritizing, and interpreting sensory information, our brain allows us to navigate a world full of stimuli, making sense of the chaos and ensuring our continued survival. This complex process enables us to focus on what truly matters, helping us make quick decisions and respond effectively to our environment. So the next time you experience a brain lie, remember that it's not a flaw, but a testament to the evolutionary marvel that is the human brain. These deceptions are a reflection of our brain's incredible ability to adapt and thrive in a world that is constantly changing and full of challenges.